So thank you so much for joining our event. Today we talk mainly about full stack T24 performance engineering. So welcome everyone to this event. We have attendees from around the world. I really appreciate joining our event today. And my name is Joseph. I am the founder of Performetrics. I will do the intro and I will give you a walkthrough to the entire event today. We have multiple speakers. There will be Andrew. He will do a quick demo of full stack T24 performance benchmarking and observability. We have also Rakesh. He will give you kind of insights into performance consideration on the T24 platform. Maybe Andrew, you want to quickly introduce yourself as well?
Oh, sure, no problem. My name is Andrew. I'm a performance engineer located in Canada. So yes, I will be running a demo of the Temenos platform. Today we'll see a little bit of funny stuff. So yes, I'm looking forward for my part.
Very nice. Thank you so much,
Thank
Andrew.
you.
And hand over the word quickly to Rakesh for introduction of him as well.
Hello everyone, I'm Rakesh Nanjareddy. I'm a T24 technical analyst in Performetrics. We mostly work on T24 integrations, performance monitoring and tuning sessions, and also we offer T24 trainings. And in this session, we'll be discussing more about OFS, how it's designed, what are the performance considerations while we are designing any project or implementation. That's it from my side. Thank you.
Very nice. Thank you so much, Rakesh. Looking forward to your session as well. All attendees will be muted during the presentations. We have a Q&A chat. Please check it out. Feel free to ask any question in the Q&A chat. And we have hopefully roughly 15 minutes at the end of the webinar to answer all your questions. And yeah, circle back if you have any concerns, any questions. As mentioned before, today the key value for you will be really understand what is performance engineering, why it is important, and how you could mitigate performance and security risks for your core banking systems. I will give you a quick overview about performance engineering in overall. So there's a lot about performance streams and reality when we talk in the performance engineering discipline. It was very similar when Henry Ford invented the first automobiles. People were asking for, oh, I want to have faster horses. But in fact, what he invented is the automobile, the car that is more effective, more efficient. When we talk about performance in core banking systems, some organizations, they bring in more hardware, powerful hardware. They move to the cloud. Maybe they introduce agile practices. They integrate observability. But the end is performance is still not there. And performance is a lot about the details. And today we will show you what details are really important from a performance perspective and how you could deal with these topics. Why performance engineering? So there's a big customer end-to-end expectations. A lot of customers, they simply go away if performances or pages are slower than 2 seconds. Customers also realize that there's a big business impact. So even a 1 second delay could result in a 7% reduction of conversation rate already. At the same time, cost reduction, for sure, if you have very slow CPU burning services, they will kind of create a lot of CPU memory disk pressure on your end, and the costs will go up, especially when you're in a cloud environment. This is even worse. And the last topic, performance, is more and more also a competitive advantage. So a faster website will give you even a revenue push as well, because you have more conversations, you have happy customers, and your team is not really all the time bothered in doing performance troubleshooting as well. The question is always how to start performance engineering. So we in Performetrics, we implemented something like a human AI powered platform on GoBenchmark that is also available on the Temenos marketplace. We have invented a performance engineering maturity model so that you can easily, within 5 minutes, find out how are you doing, what is your scoring, and how to remediate, how to fix these concerns. Today, in our live demo, we mainly focus on remediation. So we show you how to implement continuous benchmarking, continuous performance validation as part of your CI/CD pipelines, and how to kind of validate performance gates as well. So how does this continuous performance engineering actually work? Usually you have new deployments, new features coming in, and challenge is always how to validate performance in a highly automated way. There's no time that you can go back and wait for months to get the performance validation. What you really need is a highly automated performance quality gate that will give you immediate feedback, whether you pass, you fail the performance requirements, and hopefully if you fail, let's do not deploy this to production. Let's get it fixed by your developer and again, kickstart the entire validation one more time. From a tooling perspective, how this works under the hood, we have something like continuous benchmarking, continuous observability integrated. We do it as part of a CI/CD pipeline. We start a load test. We have continuous observability using Dynatrace to collect log events, metrics, and traces, and also turned on application security validation, because in many areas, deploying a high critical security vulnerability to production is simply a no-go and absolutely unacceptable as well. Absolutely. Today, I will not give you a full overview about all the activities involved in performance engineering, but one crucial activity is to get a good understanding about your performance requirements. I personally speaking would not recommend to run a load test if you don't have meaningful performance requirements in place. So this is a sample performance requirement for T24. You have the browser channel, you have satellite applications, and at the end we would run a combined load test where we validate if there is load from both from browser and from the satellite applications, what would be the performance implication. And when you describe performance requirements, it's so important that you not only design how many concurrent users you have, but also the transaction volume that you expect. What is the response time expectations as well? Do you allow any security vulnerabilities, maybe low vulnerabilities? They're not so important, but for sure, if there are critical ones or high security issues, you should really block the release from deploying to production. You should go back and get a fix before you move on. One topic that is often forgotten is here the data volume. This will have absolutely a high impact. The more customers, the more accounts you have in your test and production environment, eventually this could impact the end-to-end response time. And this is my last slide. Show you quickly what is the design overall. So from the left to the right, we have the benchmarking for the T24 core banking system. We simulate the load using browser, API, or MQ channels. We have full stack monitoring turned on for the entire platform, web, app, and database. And we collect and inject the load and finally validate the end-to-end response times on SLOs, service level objectives, quality gates in a highly automated way. If everything is good, we have a green light for deployment to production. If we identify performance challenges, let's say response times are beyond 2 seconds in some areas, we would block the quality gate, we would raise a defect and involve the developers, environment teams to get these issues resolved. So this was my part, and I would like to hand it over to Andrew for the live demo. Stop the sharing.
Okay, cool. Thank you, Joseph, for the insights. Let's see some action. So I'll share my screen. Please let me know if you can see my screen. Can you see that?
Good.
Okay. So yes, thank you very much, Joseph. As I mentioned before, my name is Andrew. I'm performance engineer in Performetrics, and right now we will be doing some fun stuff, putting some pressure under a T24 environment. So yes, a couple of words about the tooling we are using. So as you can see here, for the load testing tool, we choose Gatling, and I'm aware that most of the people being here on this webinar are aware how the Gatling work, but maybe someone is not aware. So Gatling is an open source load testing that is designed for web application. It is written in Scala language, so basically in Gatling, user can define scenarios that simulate real user behavior. So, and yeah, the Gatling is composed, these scenarios are composed on the various HTTP request mimicking actions like logging in, browsing, or submitting the forms. And I will explain how we will be running this simulation here. The application under the test is the model bank from the Temenos. This is the Temenos cloud version. And on this model bank, we will be trying to mimic two of the actions from the user. First, we'll try to execute in the command line command account L, and the command account L will likely give you back a list of accounts stored within the system. This list could include various of details about each account, such as account number, account type, account holder information, balance, currency, status, and other relevant information. So for someone who is working using Temenos, it will be a command that you will use a lot. The second command we'll be using is command stmt entry L, and we'll trying to display a list of statements, entries for the specific account. And these entries could include deposit, withdrawals, transfers, fees, and any other transactions. So actions we'll be doing on this box will grab the user. A user will logged in, will one of the user will take care of the account L statement. The other users will take care of the STMT entry L statements. And after the information or they will be able to see whatever they need to see in the Temenos, they will logged out from the system. So this is our test case. And to make things a little bit more funny, and we are using Dynatrace to see the results from the test. And with so a couple of words about the Dynatrace. We'll go with the biggest details about this platform, but yeah, the Dynatrace key features are ape-out monitoring capabilities, which enable automating detection of performance issues and anomalies. And this is very important. And by leveraging artificial intelligence and machine learning algorithms, Dynatrace is giving us vast amount of data in real time and real with the little bit of configuration needed to start catching the important metrics from this platform. So yes, I'm done with talking. Let's start some actions. So as I explained before, we will be using open source Gatling to run the test. I have here our Maven projects we built for the purpose of this event. When we are simulating the scenarios I explained before, I have two scenarios here. When you go to the Maven project, I can show you this in the tree. You have different kind of scenarios packed in our package. So in the scenarios, we have account list and statement list. So this is exactly what I explained on the Temenos model bank. And as you can see here, we are on the account list script, what is written for the purpose of that. So yes, we are passing a lot of headers. For example, I will only give you, I don't want to bore you. Yeah, we are passing some feeders and we are executing a couple of groups. To make it more realistic, between each group of requests, we have some think times because we want to mimic the real user scenario. So we want to be sure that we are doing stuff similar to the users who will be using the platform. So they won't do everything automatically, 1, 2, 3, 4, and after that they will log it out in the matter of 2 seconds. But they will use, for example, they will read some data from the statement or account list. So yes, we have a couple of groups here. This is one of the scenario. The second scenario, when we are talking about the account list, is very similar, but it's different because we are catching of these different of the values. We are catching a couple of the session details, and we are passing it through. We are passing it through the test. So this is our second scenario we'll be running, and on top of that, the cherry on this cake is our main simulation. So main simulation is responsible for running the test through it. So we have here the second setup when we are injecting the amount of 20 concurrent users, like we are ramping up to 20 concurrent users for the amount of 5 minutes. After that, we are executing the second statement after a little of the break. And also we are executing it for 5 minutes. When you are using for example, Maven, then that will give you a compiled jar file, and you will have opportunity to run it. You can run it in terminal, but for example, you can run it also in the CI/CD pipeline. You can use Jenkins for it. You can integrate it with whatever actions and whatever projects you have in your bank. So as you can see here, I'm grabbing the jar file that I generate before this event, and I want to run it through my simulation class. So let's start the thing interesting. Let's start the test. That should start running. We'll see a lot of details here because in these particular scenarios, we are catching a lot of values, a lot of sessions, and we are passing it through because I want to make this script a little bit interesting, that we have some actions. As we know, this load will take 10 minutes, so we have a little bit of time. So I will switch to Dynatrace to give you a bit of overview of this platform and how we will use it and what is the difference, because the Gatling will also give us some details, some reports, and what is the difference and why we are using Dynatrace. That will be also important. Okay, so let's go back here. The test is running, and yes, I want to mention that we are running quite big load on the very, this is not a big box, because I will show you details about the box we are running the test against. And I'm on the Dynatrace app. and I want to see the host. And under the host, I will have the host when we drop one agent from the Dynatrace.
Andrew?
Yes.
Can
yes,
I ask
yes.
a question from the
sure.
audience
Sure.
regarding whether we are using full stack tracing? Was the question for T24?
Yes, we are using full stack tracing in Dynatrace, as I will be showing you shortly. So yes, this is not only an infrastructure, but the full stack. And yes, as I mentioned before, we drop Dynatrace one agent on this Temenos box, on this Temenos host. And what is the beauty of the Dynatrace? That from basically moment you will drop your one agent, and one agent will start operating on the servers, you will start having the meaningful metrics about host performance, about process analysis, and you will see all of the processes on the host. So this is full stack. You are not seeing only, for example, infrastructure, but you are seeing everything, and you can see all of the services and processes that running. You are seeing technologies used on this particular box, and this is only beginning. So yes, you have 5 pages of different services run on this box. You can also analyze your disks. You can see the network analysis and basically all of the details from this particular host. And this is done with almost no configuration. Of course, the configuration for the T24 using Dynatrace will be a little bit different story. But for example, we have our fastpack because we cracked it down already how to monitor T24 using Dynatrace. So yes, as you can see here, you have a lot of data. So this is very important topic. Let's see I will switch back a little bit. I will be jumping through the topics because a lot of things going on. We are running a lot. Let's see the load, if it's still running good. Yes. Statement entry and all the funny stuff. You know, one time I was on the airport and I was executing the load, and someone was passing me through because this is looking like you are coding a lot. Yeah, you are running a test through the command line, and the people can think that you are so advanced coder, what you are, but most of the stuff is running automatically when it's set up correctly. Okay, cool. The test is running. So let's go back to Dynatrace for a moment. So Dynatrace will give you full stack visibility and observability on every aspects you would like to have, and you can start from the dashboards. The dashboards are completely configurable, and you can see a lot of data. What is okay? Let me go back to classic. On the classic dashboards, let me relaunch it. To see the results, I will wait till the test will finish. So yes, as you can see here, we have T24 Transact Service Level Objectives dashboard that was configured by us for this box, and I will show you a couple of details how you can configure it and what the details would be crucial for you when, for example, you have that important platform. And yes, Dynatrace is a very advanced platform. It's used AI-powered monitoring capabilities, but you need to have good understanding what you are monitoring to see the beauty of it. And for example, you can go from the dashboards, all distributed traces. You can go back to the code level to be able to see whatever is going on your environment. Host Classic has showed you problems. We'll see if our load will generate any of the problems. So let's go back to our test. And okay, cool. I was talking for 10 minutes. So yes, we finish our test using Gatting. And what Gatting will give us? Let's go to the file. I will grab this HTML and I'll try to post it here. Okay. This is our report. Our test is finished and our test was successful. We have we simulate a lot of transactions. I think we simulate around 50 transactions per second. So for the box, okay, I'll go back for a second because I want to show you the details about the box. I said that I would do that, but I didn't. So I'll go back. Let me see the properties and tags. And this box we have 31 gig. So it's quite a small sandbox for the purpose of the testing of, trying to monitor it. I guess that the big organization will have bigger Temenos environment. And to be completely honest, that this box take this big load quite handy, I would say, because most of our requests are less than 800 milliseconds, what is cool because we are logging in, we are executing some load. And what the Gatling report will give us, basically, it will give you response times, it will give you what kind of errors you had. We had 8 errors, but it was expected that that will happen in this load. And it will give you response time distribution, response time percentiles, and number of requests per second, number of response per second. Okay, this is good, but for us as a performance engineers or observability engineers, that can be not good enough. We would like to understand what happened under the environment and what we hit. So let's switch back to Dynatrace. So we'll be basically talking a little bit more about the Dynatrace. So here, for the purpose of this demo, we prepared load testing configuration where we are catching the load. Okay, one thing I forgot to mention. As you can see here, in our main simulation class, we are passing a header from Dynatrace, and this header will help us to catch all of the related data and to store it in the Dynatrace. How we know that it happened? Okay, let's go back. And I will go to the load testing request, what is built to catch it out. And let's see the load. Yes, sweet. This is our load, and there are our details about it. So as the Getting report show us, the response times will be quite similar. As you can see here, this is funny stuff starting. We are seeing all of the requests we hit with our test. For example, we will be analyzing the browser login. So the user logged in, but this is not good enough. This is a response time average 115 milliseconds. Sweet, this is fast. Our box, the Temenos box, handled it quite very well, I would say. So I would like to see more details about what happened. So in the Dynatrace, I can switch to service flow, because what service flow does, it will give us the visual representation, what are the services and processes we are hitting on. As you can see here, we can go and see that from our test, we are hitting T24 browser, we are hitting the load, and after that, we are hitting the database. For us, great news, because, for example, if something went wrong or we we simulate the load, and the beauty of it is you can have different kind of tooling that will simulate load like spotless, but you need to have the way to analyze the results and understand what happened. So for example, for this one, for the logging in, we can drill down even more. We can view the distributed traces and our request, And from the distributed traces, you can trace it, and you can see all of the SQLs and all of the details, whatever happened in the environment using this one, and what kind of statements were executed, all of that. So basically, you will have a Ferrari that when you know how to drive, it will be very, very good and very handy to use. So Dynatrace is giving some the question we had, if this is full stack monitoring. Yes, it is. You can even go to the code level and see all of the posts or the statements on whatever you did on the code level. And other than on top of that, you can go through your codes exactly and what kind of details were executed. So yes, for us it's very nice, because as you can see on the login on this particular request, we had no errors. That's implication that the login was successful. What else we can see in the Dynatrace? I would like to see if my load generate any problems. And automatic problem detection in the Dynatrace is great. And ladies and gentlemen, for the last 30 minutes, we see no problems. So our test didn't overload the environment. Yesterday, when I was running the test, I see some problems. So I will switch back to last 24 hours to see what kind of problem and how the Dynatrace detected. There are problems from the load, because other than that, we don't have problem on this box. So for this example, I grabbed the response time degradation problem. So I can see exactly what service was impacted, what are the degradation, and for example, we exceed the auto-detected baseline for quite a lot, 2000%. And yes, from this menu, you can drill down and down to all of the details, to all of the database statements, and what the statements was responsible for this particular error. So yes, as you can see here, you can go very deep to understand how this is affecting your system. Okay, we can talk forever about it, but I will switch back to the dashboards. Let me go back to the dashboards. I hope you are still awake. Okay, two important dashboards I would like to mention. One is T24 Transact service level objectives. That will be very useful for your management, or for anyone who would like to understand how your application is working and how many users are satisfied, what is T24 response times, and for example of this one, TCA jobs rate. And yes, as you can see here, we have some reds, but I was expecting to see some reds that mean, for example, not all of the users are satisfied. The reason of that, we are simulating heavy load on the very small box. And so we are trying to show you meaningful results in the Dynatrace. But if you will see something like that, you will know where to go to analyze what give you the reason, and how to go back to the satisfactory service level objectives for the current application. Okay, let's go back, because what is my timing, Joseph? Okay, I'm finished. I promise I will finish in a second. I will finish
4
on
minutes.
the last
4 minutes.
Okay, I have 4 minutes. Wow. I will finish on the last dashboard. And the dashboard is T24 health overview. When we are seeing all of the service health, the health of our host, the database health, and how many problems we had. As you can see here, we have no problem. But I guess when I will switch to last 72 hours, yes, this is still okay. We had no problems here. So yes, you can see all of the response times, throughput, errors, and for example, time spent on database. You have all details about your infrastructure as well. And from this one, what is also the nice thing about the Dynatrace, you can drill down for whichever details you would like to. So all the I would say that dashboards are living. So basically, you can go back to the data source and the picking the data from, and you can drill it down there. So yes, we can spend another couple of hours to talk about the Dynatrace, to talk about how we are simulating the load. I hope that you had a good time on it. As we can see here, we'll go back to our test for a second. Most of our requests passed, only a couple of the chaos, but for the amount of 17,000 transactions, having only 8 chaos, that means we did a good job. So yes, I'll finish here. Yes, I would like to thank you for listening to me. I hope that you didn't fall asleep during my presentation. And right now, I will handle it to Rakesh. Okay, I will stop sharing my screen right now.
Thank you so much, Andrew. Was a pleasure, very insightful. And Rakesh, maybe you can continue sharing your screen.
Yeah, sure, Joseph. Hello, everyone. So thanks for your session, Andrew. So let me introduce you to this T24 and OFS. Yeah. So the T24 resources, whoever started working on it will see this diagram in their first session. So let me explain this architecture diagram in a different way with respect to our OFS here. So this security management system is nothing but the login credentials which we use to log into the T24. And then after that, Andrew was explaining about the account and statement entry. Let's take an example of account. Account is a module here. So these are all the modules, customer account, all the modules present in the T24. And these modules, data will be stored in the database, which means there are 10,000 accounts. If there are 10,000 accounts, 10,000 records will be created for that particular application in a database. So in order to read or write into the database, we'll have to have a valid T24 credentials here. So this is inside part. So how we will write something into T24, account I and the account ID or account new creation, something like that. That's the one which we will execute through browser. And then to read something from the database, what we will do is account list, filter it out and read it. This is the first approach, the first way we can write and read from the T24. And then comes some other approaches. In order to write something into the T24, we have something called customized look of an application. That's called version. So, for example, accounts are customer if it's having 2,200 fields in it, both core and local. We want certain fields to be updated through a version. For example, a customer name has to be updated with a version. So we can design only few fields like this particular field to update it, and then that becomes a customized look of an application with only one field or two field, something like that. But we have to be careful while designing a version. If it's just for an update, we can give few fields, but if it's for inputting, we'll have to give all the mandatory fields and everything. So this version we'll use to update that particular record that will be stored in this database. Again, if you want to fetch the same details, instead of going to account list this particular account ID, we can create an inquiry with an account ID with it and following fields, or customer with following fields, name.1, something like that, and then we can read it. So this is also inside the T24. Everything is inside. So how can we communicate to T24 from outside world? Even if it's a browser also, it has to be communicated with the OFS source. we have something called Open Financial Services, OFS, to communicate to T24. So in another way, we can call it the language which T24 understands. So it's just a string through which you can pass some commands into it for writing something into it and then reading something from the database. So from outside world, we can communicate to T24 through OFS. This to different OFS sources. For browser, we have different source. For ATM, we have. For mobile web applications, we have different source to which we can communicate. So irrespective of what language or what type of coding the other third-party apps use, the final output to the T24 should be OFS. And then let's see here. So this is the string of OFS. So let me explain this. I told you we should have valid credentials to log into the T24. So that credentials has to be inputted here in this format here. Input and password or Rakesh, my password, something like that. And then after that, in order to write something into T24, I told we need a version. That version has to be inputted here. Version name followed by here this I and process key. Here for inputting I and then process key should be process. For validation, what should be there is I and validate. For verification, V and process. So we should get confused between the functions and then process keys. Mostly for everything, process keys process only except for validate. And this one will be changing I, V, R, D, depending on the actions which we need to do. And then here comes the record ID which we want to update, and then field names. So just simple. If you look at here, I need a version name, I need T24 credentials, and then I need an application, which means this version's application and its field that will be updated directly to the database. And then we have two more things to discuss here. One is GTS control and number of auth. For most of the financial transactions, the number of auth should be set to 1. So in this string, whatever the value which we are passing takes the prominence. So we can define this GTS control and number of auth inside the version as well, but whatever we are defining here will take the prominence. So GTS control is to tackle this error and overrides. If there are any errors, what we should do, it should halt or it should throw an error or it should be in hold. If there are overrides, it should approve or it should reject it. Like that, we can decide depending on the codes which are giving here. So this string is formed just by looking into this architectural diagram from here to here. And then the next string, let's go to another string. Here, I took an example of industry. If you want to fetch account as well, we can give the core inquiry name percentage and account. Or we can also create an inquiry name on our own basis and define it here. Here also same thing. We need our credentials. And then this is syntax for inquiry, inquiry.select. And then here, inquiry name followed by the fields. Which fields we want to filter it out, not to get here. Which fields we want to get should be defined in this inquiry. Which field should be filtered, it has to be defined here accordingly. So we'll get the output accordingly. So this is the way we communicate to T24 from outside world through this string. So these are the strings. So this can be formed inside a routine. And then this can also be passed from third-party application after the conversions. And this can be done in many ways. So here, these are the OFS source. For example, our browser session is the OFS source which we'll be using for inter-application processing, Globus, batch for third-party offline, and telnet for third-party online processing. So here, like I told you, the function and then the process key will have to be clear on that. So one validate will be only applicable for validation, other everything is for process only. And then verification, this will be applicable for only few of the applications, few of the functions like build control, inquiry reports, and all those things. And best practices is this GTS control. This has to be passed in OFS string rather than the version level. Depending on the versions, In some versions, what happens, they might not be defining properly, or else in the other way around, it has to be in the versions itself, not in the string. Either has to be followed, both has not to be followed accordingly. And then we have something called NAU processing. What is this NAU processing means? Suppose if any transaction is in not authorized stage and we want to rewrite it or reject it, keep it as it is, what we need to do. Not authorized not only means just the not authorized one, newly created one, the deleted ones, which means reversal ones as well. So we'll have to reject the OFS message which we are passing the second time, or we'll have to overwrite it and give the second string chance to update it accordingly. So this is the prominent one. Sometimes most of the strings will go to hold most of the updates. Then again, if you want to update it with a different data, then we'll have to give this one override. And then after sending the string, we get 1, -1 like that, success or failure indicators. 1 means success, rest all means something is missing, some issue is there, something like that. Then let's go to OFS performance tuning. So for example, let's take an example of ATM. We are requesting for our bank balance. So what happens here is ATM switch in ISO format sends a message to T24 ATM interface nice format, and then in ATM interface it converts it to OFS and then send it back to T24 for requesting the balance, then back to OFS format to ATM interface, back to ISO to ATM switch. So these three parts will be there here. So let me explain. From third party app to T24, what is the time? And then inside the T24, after getting the request, after conversion of OFS, it has to pass through EJB MDB layer sometimes, and then it has to pass to offline and online queue sometimes, and then it will hit the T24 processing thing, which means inquiry, inversion, OFS things, and all those things. So we have divided it into three parts. Suppose it's taking 100 seconds to get a complete end-to-end response. In that, 40 seconds are being done in this third-party application to T24 only. And then back to T24 to third party, 40 seconds, something like that. 30 in this part, 30 in this part. Most of the traditional approach of performance tuning goes here, which means they just take this is the place where there should be an error. They check the OFS level routine and then inquiry, no file inquiry, all those things. OFS source, they'll try to minimize the log levels and control it, all those things. But what will be happening is they can minimize 10 to 15 seconds, but still 85 seconds will be there here. How can we do that? How can we minimize it? By checking all these aspects, not only checking the OFS processing time in T24. So like this, we have many approaches, like out of the box approaches for each and every module, each and every request and response times, not only in the OFS, in all the other aspects as well. And in this way, we can tackle all the OFS requests and ease the processing time for that. And then, yeah, that's it from my side. Over to Joseph. Let me stop sharing. Thank you so much.
Thank you so much. Thank you so much, Rakesh. I will continue. I hope the sharing is working.
Yes, it is. Yeah.
Very nice. So thank you so much, Rakesh. It was nice learning about OFS, or what is it and how we can tweak it, tune it for better speed, better throughput. So I want to just give you here a couple of further readings. The first one is our Go benchmarking performance maturity model. Check it out. You can get started for free. Second topic is we have a few hundred of blog posts on performance and T24 topics on our website. Check it out as well. If you face any core banking performance challenges, we are specialized in trainings, observability, performance tuning, security testing. So let us know. We are happy to support you in that area as well. We are partner of Temenos and Dynatrace. We have our products also on their marketplace. So in that area, we have a lot of knowledge, more than 15 years in the banking industry, and Dynatrace the same time, roughly. So it's a big pleasure to have all of you in our webinar today. And I would like to open the floor for any questions. Do we have anything in the Q&A
Yes, yes, we have a lot of questions, and I would like to mention, because we have only couple of minutes more, that if we won't grab your question and answer it right now, we'll simply send you email with the details and the answers, so you won't be left alone. So yes, Joseph, I have a couple of good questions. So the first question I would like you to answer. So the question is, what is the effort to implement load and performance tests?
Oh, this is a tricky question. So it depends really on the type of load and performance tests. When you do something that we demoed over here, for sure you need to invest a few days. It depends all, do you have performance requirements in place? Do you have a proper UAT to run all these tests in place? Always make sure that you start understand your performance engineering maturity. Go back to our maturity model. You would see the rating of yourself and the remediation plan in a few minutes. And then depending on your rating, we could easily estimate your effort. So the first part is kind of self-service, and then implementing it, performance testing is another topic. Usually you have 10, 20 use cases you want to automate. So something between 10 and 20 days is usually a good starting point to get it implemented, create performance benchmarking as part of your pipeline, and have something like Jenkins, GitLab pipelines in place so that for each and every release, you can automatically validate it.
That's great. Thank you so much, Joseph. I will have one question for Rakesh from Cuba. How many performance problems actually originate from poor OFS design as opposed to poor version design and wrong tables views used? So, Rakesh, if you can elaborate.
Yes, Andrew. Actually, I was typing it. So
that will be easier.
usually, poor OFS design and environment setup led to most of the performance issues as we came across. We are fine-tuning many of the bank's environment where this OFS design environment setup took most of the time rather than this version and inquiry time. So, but significantly, most of the time they see this version and inquiry and they try to fine tune it further and further, but there is a limit for that. But we'll have to handle it in this OFS source level and then environment setup that way. That's it.
That's great. Thank you so much, Rakesh. Kuba, let us know if that answered your question or you have any follow-up questions. And before you do that, I will answer one question from the audience. The question is, should we start with load testing or observability? And I will say always observability first. Why? Because when you will be running the load test, you want to have the way to analyze the results and to drill down to the problem caused by your load testing. So yes, even why you should use the observability before the load testing, because when you apply the good observability on your servers, then maybe you will not need a load testing to analyze the results. I mean, you can see a lot of details and possible a lot of problems on your environment even without the load test. This is this is our experience from our projects, that from the moment when we will deploy the observability, we have, this is like a eye opener for us and for the clients to see what is going on the environment. Because even when your system is not breaking down, it doesn't mean that it's operating correctly. So I would say observability first, and when you apply observability on your platforms and you will you will reach the moment when that details and the data from your observability without the load test is quite satisfactory. You can start hitting your environment with the load test, and for example, you have different version and different deployments. Then yes, so to elaborate it, I would say observability always first, and after that, load testing. And one question also I'll grab, because we have only 3 minutes, so maybe Joseph will answer this last question. What is the performance impact of Dynatrace tracing?
Good question. So our largest customer trace on production, even huge trading platform, when they have 20 million and more trading requests per day. So the performance impact, we did already benchmark tests, is almost not measurable. We are talking of a couple of milliseconds. Based on our experience, you can neglect it. And by the way, if, for instance, your machines would run high on CPU and memory, the OneAgent has also a built-in self-protection mechanics to kind of switch to a sampling mode to no longer kind of collect all the transactions, just to protect your application servers as well. But based on our experience, no performance impact. You can fully deploy it on production as well. But always, usually we test it out on UAT. It's more from a functional perspective to make sure that this is no challenge. There are sometimes really, I would say, in 1 of 100 cases, there can be an edge case from a functional perspective, but performance-wise, we have not experienced any performance impact after Dynatrace was deployed.
Wow, Joseph, thank you so much for your answer. And yes, we had a bunch of questions in our chat, but we'll answer them after the event, because we have only, I think, 30 seconds left. So yes, that's all from us. So right now, I would like to thank you for each and every of you for attending the webinar. We'll be sharing the recording from the webinar soon, so you have the option to go back to the details we shared, because it was a lot of data that we generating through the event, and a lot of informations that yes, maybe you need to go back to it to have the more questions. So please, once again, thank you so much, and please contact us if you have any performance or observability needs. We are here to help. So thank you so much, Joseph. Thank you, Rakesh. That was cool event.